students. So in today's video, we would be doing a lot of practice problems on quadratic. In the last two lectures, we have seen different techniques, of solving factorization, right? So we have seen the difference of square method. We have seen how do we take, the or eliminate the common factor. We have seen how to use the identities. We have also yesterday seen the sum and product types and the midterm splitting, right? So as and when we went through any of those, we went through the theory and we solved, the corresponding problems. So obviously it is very easy as a student to, immediately start working on that, right? But say, obviously in an exam, all that would be asked is factorize this given expression, or you may be given an equation and you may be asked to solve it using factorization, right? So which means obviously there would be no obvious indication which particular form does it belong to. And as a student, we have to find out that which form of factorization would it fall into, and how would I factorize it. So we would just do that. So that's why today we have this curated sheet of 22 problems, which I have also shared in my thumbnail, right? So so obviously they are jumbled up, so you don't have all the problems of one particular type together. So that as a student, we would think what the form does it belong to, and obviously thereby start solving it, right? So let's get into the practice session because it would be a long and marathon one, right? So let's get started solving the first problem. So the first problem says y into 2 plus y minus y minus 2, right? So I have got three terms in this expression, right? So term 1, term 2, term 3, and term 1 is also expressed as factor of two things, right? And I want to do the factorization. Now, so if I see here, one way I can think that I can open it up. So if a student opens it up and finds out that it will be 2y plus y squared. So if a student finds out that it is nothing but, he or she does the expansion of the first term, and it becomes obviously 2y plus y squared minus y minus 2, right? So this is one way. Okay, so obviously after doing this, you may rewrite this problem like this, right? That this is nothing but 2y and your y square, let it be the first term, plus 2y, bring this minus 2y closer to this, minus y minus 2. And the reason, obviously we know, your which law or which property of addition is nothing but your associative property, right? Associative property. You can jumble up, the terms in the expression, it doesn't really change. Now, if you do this, so you can easily see that there are multiple ways of solving it. A, you can now add these numbers together and you arrive at y squared plus 2y minus y is nothing but plus y minus 2. Okay, so now I'm getting y squared plus y minus 2. So I have arrived at a quadratic trinomial, right? So the highest degree of y is 2, and there are three terms, so I have arrived at a quadratic trinomial. Now, to solve this quadratic trinomial, I know that minus 2 or 2 can be 2 can your, as we have seen yesterday, right? Your sum and product type. So this term is minus 2. So I can write that obviously the two factors of minus 2 could be minus 2 and plus 1, right? So minus 2 into plus 1 is minus 2. And but if I add them, it would again be minus 2 plus 1 is minus y. So which means I'm not getting here, right? So let us do it like this. So if I put it as 2 into minus 1, 2 into minus 1, I'll still get your 2y, and here if I do plus 2 into minus 2, sorry, plus 2 plus 2 plus minus 1, I am getting the middle term, right? So this expression can be expressed as sum of these two and product of these two. So which means I can rewrite this as y squared plus 2 plus minus 1 into y, right? Plus 2 into minus 1. So if you see, the middle term is expressed as alpha plus beta, and these two are expressed as alpha beta. So we know if we have an expression of the form of x squared plus alpha plus beta into x plus alpha beta, then the factors of this is nothing but x plus alpha into x plus beta. So this is what we have studied as an identity yesterday, right? So using this identity, you can quickly say that the solution for this would be y plus 2 into y minus 1 answer, right? So this is, so we had used, so if you say first we used expansion, then we used, your bit of associative property of, summation, and then finally by using the sum and product type of your quadratic trinomial, we solved this factorization. So this is one way, but obviously I went to the longer way. There's a much easier way in which you can solve it. Just type it down and then I will show you what is the easier way of solving it. But let us still retain the answer so that we'll compare the answer. Okay. Now let me erase the other steps, and I believe you would have already noted it down. Okay. So now let me solve it much in a much simpler way. So if you see, right, this expression can be rewritten as 2y plus y squared. Okay. Now we know that. Okay. So let me not even expand it. Okay. Let it just be even right here. Y into 2 plus y minus 2, because my aim is to factorize, and in factorization we move from the expanded form into the factor form. So I don't want to further expand it. Okay. So I would not disturb the first term, y into 2 plus y. Now I know that if this can be expressed as a term such that there is a 2 plus y factor here, then between this term and the new term, I can take 2 plus y as the common factor and it can be easily factorized, right? So let me see if that is possible or not. So if you notice this problem, when you have got minus y minus 2, if I take between these two terms, if I take a minus 1 as the common factor, then this will be minus y by minus 1 is nothing but obviously your plus y, right? And minus 2 minus 1 is nothing but plus 2, right? So now if you see, y plus 2 obviously can also be rewritten as y into 2 plus y minus 1 into 2 plus y. So obviously now this is the common factor between these two terms. So if I take 2 plus y as the common factor, the remainder is here. From the first term I get y, there's a minus sign, and here I get minus 1. It is 2 plus y minus 1. You get the same answer, right? So that's why we obviously say that mathematics is like methodology. You can follow different paths, or it's like a treasure hunt. You can follow different paths to reach your or answer. Okay, so you may type it down, but and I would obviously recommend this as the best method for solving or factorizing this, for the fact that what are the steps we have studied in factorization. The first and foremost one says eliminate the common factor. So here, as I have eliminated the common factor, in my view, this is the best way of solving it. However, if you follow the previous one also, that's right. Nobody is saying gonna say that as wrong as well. Okay. So hope you would have already written this. So now let's move on to the second practice problem. Okay, second practice problem. So we have got 3ab minus 6b. So if you see again, our step one remains same. Eliminate any common factor that is available. So what is the highest common factor? I can take 3 and b. Both of these are a common factor among these two terms. So if I take this as common, then the first one becomes your a, right? 3ab by 3b. So 3 cancels out, b cancels out, a remains, here, minus 6. So obviously now it cannot be factorized further, and this becomes your answer. And checkpoint, here it was expressed as term 1 minus term 2, but here it is expressed as multiplication of two expressions. So which means obviously this is factor 1, this is factor 2. So obviously I have factorized it. And if you see, the highest power of variable a here is 1, and highest power of variable b here is also 1. So which means the second checkpoint of your factorization is also met. So remember, the two important checkpoints to check whether you have actually fully factorized an expression or not is a, is the if a, the expression should be expressed as multiples of multiple expressions, right? And obviously then only we say these are the factors. If you have any doubt on this, either go through my thumbnail of video 1 or go to the first few minutes of lecture 1 on factorization, and this concept will obviously be clear. Okay, and the second point is highest power of each expression should be 1. So obviously that means this is fully factorized. Okay, so quickly type it down, and then we'll go to the third practice problem. Okay, so I obviously use the time which I asked you to go through or note it down to drink a couple of sips of water. Okay, now let's go to the next practice problem. That is 9a square b square minus 16. Very good. So now 9a square b square minus 16. What is my step number 1 of factorization? Check if there is any common factor across all the terms, and if yes, then eliminate them. Obviously, there is no common factor among the terms, so I cannot eliminate it. However, if you see, I can express both these terms as squares of something. So first term can be expressed as 3ab square, and the second term can be expressed as 4 square. There's a minus sign. I retain the minus sign. So obviously, this comes into your first identity type, that is difference of squares, right? So I know if something square minus something square, then I can write 3ab plus 4 into 3ab minus 4. And I insist you to write this, the reason, okay? So the reason is a square minus b square equals to a plus b into a minus b. So students, as I was saying in my yesterday's class also, getting into the habit of writing the reasons is a very good thing. And let me tell you again that this is a very important lesson which will help you a lot in your life, right? And as I was saying you, I see many developers in IT industry who write code, but obviously they feel it's a huge pain to write the corresponding comments, and that is where a lot of debates come up. So tomorrow somebody else want to do any kind of resolution on their code, any kind of bug fixing, that becomes a problem. And I always believe that as a student, if somebody has got into the habit of writing these reasonings, he or she would never find that as a problem, because that would be in his or her genes already by then. Okay, so just type it down, and then we will quickly go to the next practice problem. Okay, so let's keep moving. Yeah, so the next one is The next one is m squared minus 6m plus 9. Okay, m squared minus 6m plus 9. So let's see how should we solve this problem. So step number one, pretty simple and common. We know, find out any common factor and eliminate that. So here there is no common factor across all the terms. M is a common factor between term 1 and term 2. 3 is a common factor between term 2 and term 3, right? So there is no common factor across all the terms. Also, it also has only 3 terms, right? If you were having 4 terms, I could have still splitted them in pairs and would have looked for the common factor, but that's also not possible here. So I would see something else. Now, if you see, this is your quadratic trinomial. So highest power of the variable m is 2, and obviously it has got 3 terms, so it's a quadratic trinomial. So whenever it's a quadratic trinomial, first thing is look for the sum and product type, right? So as I said you yesterday also, sum and product type is a way of quickly finding the factors. If you find it difficult, you may just first do the middle term splitting for everything that is in a quadratic expression, and later you can come to sum and product type, even that is fine. Okay, but I will first solve it using the sum and product type. Okay, so now let's see if this can be solved using the sum and product type or not. Now my term that does not have any variable, it has got positive sign, which means, and the middle term has got negative sign. So I know that if both the terms are negative, so if I can write that 9 is equal to minus 3 into minus 3, right? So minus 3 into minus 3 is plus 9, and minus 3 plus minus 3 is nothing but minus 6. So this expression can be rewritten as, right? If you see here, this expression can be rewritten as your m squared plus 1 minus plus, I'll put up your curly braces here rather. Okay, so minus 3, I could have written minus 3 minus 3. So just to show it perfectly in the formula style, I have written minus of 3 plus minus of 3. Okay, so your, if you see, so it can be expressed as your x squared plus alpha plus beta into x plus alpha beta. So this is your alpha minus 3. This is your beta minus 3. So minus 3 plus minus 3 is minus 6. Minus 3 into minus 3. It is alpha beta is plus 9. Right? So now this is a simple, your sum and product type, your quadratic trinomial. So I can write, obviously the factor would be m plus minus 3. So this will be first term into m plus minus 3. This will be your second term, right? So that is nothing but m minus 3 into m minus 3, right? So I solved it using sum and product type method of factorization. Now, can I solve it using some other ways? Absolutely yes. So let us see what other ways can we solve this problem. Okay. So if you notice here, this problem also is of the form of, oh, your, okay, a square minus 12b plus b square format. How? So 9 can be written as minus 3 square, right? First term is nothing but square of m, right? Minus 2, a here is m, b here is minus 3. So if you see, nothing is changing. M square can be written as square of m minus 6m, 2 into m minus 3. Sorry, minus, okay, so this will be plus 3, I'm sorry, okay? And the last term will be 3 square, right? So 2 into m into 3. So 2ab plus b square. So if you see, a square minus 2ab plus b square is nothing but a minus b whole square. So, and the reason is, as we know, a square minus 2ab plus b square equals to a minus b whole square. We had studied this identity as well. So if you see in this way also, we are getting the same answer. The answer in the technique one we have got was m minus 3 into m minus 3. So that is obviously nothing but m minus 3 whole square. Same thing, right? So this is probably technique 2 to solve the problem. Is there a third way of solving the problem? Yes, there's a third way also. Let's see what is the third way. Okay, there's a third way also. So what is the third way of solving this problem? Let's see. So I know this is a quadratic, expression. So as I said you, whenever you are getting a quadratic expression, you can blindly use middle term splitting, right? So if you express this as your, suppose if it is your ax squared plus bx plus c format, then obviously your a here is coefficient of m squared, that is 1. B is coefficient of the middle term, that is minus 6, and C is nothing but plus 9 here, right? And you know that we split the middle term into m and n such that m plus n equals to b. So that is nothing but your m plus n equals to b is nothing but minus 6 here, right? Similarly, your mn equals to ac. So if mn equals to ac, so obviously your mn will be a here is 1, c here is 9. So 1 into 9, that is nothing but 9. M plus n is minus 6, mn is plus 9. So obviously m minus n will be root over of m plus n whole square, that is minus 6 square, okay, minus 4 into AB. AB is plus 9. That's so 4 into 9. So that is nothing but minus 6 square is 36 minus 4 into 9 is 36 root over. So that is nothing but 0. So if you see, if m minus n equals to 0, so can I say that m equals to n? Right? So now if m equals to n, I can put this value of m equals to n in any of these equations, right? So m plus n equals to minus 6. So if m plus n equals to minus 6 and m and n are same, then I can say 2m is nothing but minus 6 or m is nothing but minus 3. If m is minus 3, obviously now I can rewrite this equation as if m is minus 3, as m is equals to n, so obviously your n will also be minus 3. Now I can rewrite this expression as m squared plus m squared plus your a plus b into m, right? So that is nothing but minus 3 m plus, right? That is nothing but 9. Okay, so if we just further expand it, then this would be m squared minus 3m minus 3m plus 9. Now if you apply grouping by pairs here, take these two as one group, take these two as another group, right? So between these two common factor is m, so the remainder is m minus 3. Here also the common factor, if you take minus 3, then you will get m minus 3. Now between this term and this term, the common factor is m minus 3. So obviously the remainder here is m minus sine 3 m minus 3. So if you see here also we are getting the same answer. So my intent is to help you understand that mathematics need not be mugged up like some other disciplines of studies, right? So you have multiple ways of solving the same problem. So whichever strikes you in exam, go by that. But for solving this problem, I personally would prefer if somebody expresses it as a square minus 12b plus b square format and uses the identity and directly say this is nothing but, as we have solved in the second style, right? That m squared, right, minus 2 into m into 3 plus 3 squared. So that's why this is nothing but m minus 3 whole square. So I would prefer this as the best way of solving it, but I have shown you three ways of solving it. Whichever you like, obviously you can solve using that technique. Okay. Now let's go to solve the next practice problem. That is y squared minus 4x squared. So another reason why we are solving using multiple techniques is for you to understand that obviously that there is no hard and fast rule that a particular problem belongs only to one particular category. You can factor it by using many times many different alternate techniques also. Okay, so y squared minus 4x squared. Now let's solve it. So very simple, that this, that step number one, there is no common factor. If there is no common factor, but I can see that I can express it as difference of squares, right? So that is nothing but y squared minus 2x squared. So obviously this is nothing but y plus 2x into y minus 2x, and don't forget to write the reason. The reason is as a squared minus b squared equals to a plus b into a minus b. Okay, so this is your answer. Okay, very easy problem. Okay, type it down and let us go to the next one. Okay, so let me erase it. Let us go to the next one. So next one is your 4t minus 8t squared. 4t minus 8t squared. So step number one, very same. If there is any common factor, let us eliminate. So obviously the common factor between these two is 4 and t. So if I take 4t as the common factor, what is left with is 1. 40 by 40 is 1 minus 2t. So this is your answer. Very simple, one step, because I cannot solve it for further. And again, if you use those two checkpoints, a, initially it was given as sum or difference of multiple terms, and you have expressed it as term 1 into term 2. So obviously these are nothing but your factors of this expression. Okay, and then the highest power of the variables in any of the factor is obviously 1. So which means this expression is fully factorized as we have put it on the board. Okay, so this is pretty simple. So let's go to the next practice problem. The next one is slightly twist. So 40 minus 8t squared. Okay, 40 minus 8t squared. So if you see here, there are again multiple ways of solving it. Step number one, you can say that the common factor across both of them is 4. So if I take 4 as common factor, then I'll get 10. 40 by 4 is 10. Then there's a minus sign. I retain the minus sign. 8t squared by 4. So 8t squared by 4 is nothing but obviously 2t squared. So if someone writes like this, right? So 4 into 10 minus 2t squared, and write this as an answer, I would say that this is not fully factorized. Why? So you can say that, sir, this is one factor, this term is the second factor. Very good. So yes, you are right that these two are factors. So first checkpoint is met. But I have been saying you repeatedly that every factor, or the, if you take out any of the factor, the highest power of your variable should be ideally 1. If it is not 1, then ideally it should be further factorized. Yes, there will be certain situations where it cannot be further factorized, I understand. Or here, if you want, somebody says that, okay, I'll take 8 as a common factor, and here somebody is getting 5 minus t squared, right? And somebody says that, sir, this is factorized. No, it can still be further factorized. So if you just stop here, then obviously this is not the right answer. However, however, if we do not stop here, right? And if you see, this term is already fully factorized. So now my aim is only to fully factorize this part. So I can assume as if this is not there, and I can just go ahead and factorize it. Okay. So I can do it like this. So this is nothing but, let's say, 8 into, let us give a name to this, factor. So let us say 8 into p, and now here I'll leave it as equation 1. Now I will separately factorize p, and I put the value of p here. Okay, so now I know p is nothing but my 5 minus t squared. So I want to factorize this. So if you see, this is nothing but, again, your difference of square. So I can write it nothing but root over, so root 5 squared minus t squared. So that is nothing but root 5 plus t into root 5 minus t, because same thing, a squared minus b squared is nothing but a plus b into a minus b, right? So now if you see this, factor p, which was 5 minus t square, is fully factorized as root 5 plus t into root 5 minus t. And if you see here, this is one factor, this is one factor, and highest degree or highest power of variable in both these expressions or both these factors is 1, right? So which obviously means now this is fully factorized. And if you put this value of p in equation 1, so say this is your equation 2, and the next step you can write down that by putting the value of p in your equation 1, what do we get? Just put it, right? So this is 8 into root 5 plus t into root 5 minus t. So if you see, now this is one factor, this is second factor, this is third factor, right? So this is expressed as multiple of three things, and the highest power of the variable in each of these factors is 1 only. So obviously now this is fully factorized, and this is the right answer. But again, I used a very lengthy technique. This can be solved even much easier. How? So if you see here, right here, yes, it is true that there's a common factor across them, right? But if you want, you can still say it as, this is nothing but root 40 square minus your root 8 into t square. Okay, so remember, when your when you have only two terms such that one other term is a perfect square of a variable and the other one is, just a pure number, the easiest way to go ahead is this identity, a square minus b square, right? So you have expressed it as a square minus b square. If you want, you can rewrite it slightly. So root 40 will be nothing but 2 into root 10. Why? Because root over of 40 is nothing but 2 into 2 into 10 root over. So out of these two, I get 1, 2, but here there's only 1, 10. So I'll get 2 that 10. So we have studied this in our radicals and surds, right? So this can be rewritten as 2 into root 10 square minus. Similarly, 8 is nothing but 2 root 2, so it's 2 root 2 t square. So if you want, you can rewrite it as 2 root 10. So this is your A plus B is nothing but 2 root 2t. A plus B into 2 root 10 plus 2 root 2t. A plus B into A minus B. And again, here you can write the identity that A square minus B square is nothing but A plus B into A minus B. Okay, so here if you want you can stop here, but I would recommend that as there is a, so if you see across all these terms, right, there is a 2 root 2 which you can take common. Okay, so if I take 2 root 2 common across all of these, then this would be, so from here 2 is gone, from root 10 root 2 is gone, so I'm left with only root 5, right, plus here 2 root 2, the entire coefficient is gone into t, right? And between these two, so from here 2 root 2 is gone. So the remainder is nothing but your only root 5. And here again 2 root 2, the entire coefficient is gone. So this is nothing but minus t. So if you see, even by following this format, we are getting the same result. So 8 is nothing but again your 2 root 2. So similar. So no big difference, right? So you can solve any problem using multiple ways. So that is the beauty of all these solutions, right? So let's move on. Let's move on to the next practice problem, and let me again sip a couple of sips of water. Okay, so now let's go to next practice problem, which is x squared minus 8x minus 9. Yeah, x squared minus 8x minus 9. Step number one, there is no common term or common factor across all the terms, so I leave that. Now, second thing, can I express, can it be, falling in any of the identities? No, it will not fall in any of the identities. It doesn't look like a square minus b square format or your a square plus 2ab plus b square, because the last term is minus 9. So had it been plus 9, we could have still thought, right? So it will not fall in any of the identity. So next, it looks like a quadratic trinomial. So let me see, can I express it as sum and product of two things? So last term is minus 9, which means the signs of both the terms will be different. And so the products will be minus 9 and summations will be plus 9. So minus 9 can be written as minus 9 into plus 1. And similarly, minus 8 can be written as minus 9 plus 1. So this much into x plus this much plus x squared. So that is nothing but my original equation, right? So x squared, I just retained it same as it is. Minus 8x I expressed as minus 9 plus 1 is nothing but minus 8 into x. I have not changed anything. Now, minus 9 I expressed as minus 9 into plus 1. So if you see, this is your alpha, your plus 1 is your beta. So here you are getting alpha plus beta, and here we are getting same alpha beta, right? So obviously by using the identity, now I can say this is nothing but x plus alpha, that is x plus minus 9 into x plus beta. Beta here is plus 1, right? So I can write this nothing but x minus 9 into x plus 1. Answer. And here we should have written that because we know if it is your x squared plus alpha plus beta x plus alpha beta is nothing but x plus alpha into x plus beta. So this is the identity which we studied in our lecture 2 of factorization. So I've used that identity to find out the answer. type it down, and then we'll go to the next problem. Okay, very good. So let's go to our next problem. And the same problem, if you want, you can use your direct factorization method, where you can take, your a equals to 1, b was how much? -8, c was -9, right? So if you want, you could have treated this as m plus n equals to -8 and mn equals to -9. So obviously your m minus 9 would have been nothing but square of 8 is 64 minus 4 into -9. So 4 into -9 is nothing but -36. Minus of minus is plus. 64 plus 36 root over. 64 plus 36 is 100. Root over of 100 is nothing but 10. So your m minus n is 10. So if m plus n is -8 and m minus n is 10, then your 2m is the summation of these two. -8 plus 10 is nothing but your plus 2, or m equals to 2, right? So you found m equals to 2. Now, if m equals to 2, you can use this one in any of these identities. So m, that is nothing but 2 plus n equals to -8, or obviously n will be -8 minus 2, that is nothing but -10. So you found the value of m, you found the value of n, just put it in the middle term, and if you do it, you will still arrive at the same answer. So that's why we have been saying that most of the factorizations can be done in more than one method, but obviously it's not again warranted that every time it can be done using multiple techniques. Sometimes you might even be able to factorize it, right? So not that every expression has got factors. Okay, let's move on to the next one. So next one is x squared minus 81. So x squared minus 81, pretty simple. This term is a square of, the term where you have a variable, that is a perfect square, right? And the other is a whole number. Very good. So I can directly write this is square of x minus square of 9. So that is nothing but x plus 9 into x minus 9. Again, don't forget to write, because a squared minus b squared equals to a plus b into a minus b. So I believe sometimes in the videos this symbol is not very clear. So in mathematics we use this symbol to indicate, or rather than writing because, right? Rather than writing because, we just use this symbol. So this is just the reverse of this one. Okay, fair enough. Write it down and we'll go to the next practice problem. Yeah. So the next one is 2g squared minus 8. Again, very simple. This term has got a variable, and that is a square, and then the other term is just a whole number. So obviously, first thing you should do, there's a common factor. So eliminate the common factor. So if you eliminate the common factor 2, you get g squared minus 4, right? G squared minus 4. Now, we just need to factorize this part and leave this part. So before some time we saw, I had, assumed this to be p. I factorized p separately. Then I, had put the value of p in the same place. So if you want, you can do that, or if you can just continue with, the same one, where you continue with 2 and just keep on, factorizing this part. So this part can be rewritten as square of g minus square of 2, right? So now this is very simple. A square minus b square. This is nothing but 2 into g plus 2 into g minus 2. right? And again, because your a square minus b square is nothing but a plus b into a minus b, write it down.